My name is Steve Nail. I am on the Scientific Advisory Board with LyoHUB. Well, my take on origin LyoHUB actually goes back to 2005. I was working for Eli Lilly at the time, as was my friend Jim Searles. And Jim was involved in a product-specific joint venture with a much smaller than Eli Lilly biotech firm. And I should say as an aside that people are generally aware that there are a lot of pharmaceutical formulations that are easily damaged by the stresses involved in freezing, freeze-drying, or both. But what maybe people are less aware of is there are a lot of formulations that are very robust against damage caused by freeze-drying. In other words, if you dry them under more aggressive process conditions, the only thing that happens is that they dry faster. And it so happened that this joint venture involved a very robust formulation, and the development scientists at this biotech company knew this early on. And if you have a formulation like that, by all means, you want to take advantage of that and be as aggressive as you can with drying, simply because it increases your output, your turnaround time. So they were dealing with that kind of a formulation and designed a process to take advantage of it. But what they were less aware of, or maybe had no way of knowing at the time, is where the scale-up would take place as they either go from laboratory scale ultimately to manufacturing scale. The scale-up was done at a third-party company. The surprise in it all was that using the developed process conditions by this biotech company, they found when they scaled it up, they couldn't control the pressure in the freeze dryer. The pressure would go up, it would hit an upper alarm limit, they would cut off the flow of heat to the shelves, pressure would come back down, they'd apply heat again, it would go back up. So you had these wild sawtooth in pressure, which indicated that the process was not under proper control, and it was simply not an acceptable process for that condition. And Jim Searles' hypothesis as to the root cause of the problem was that it was something called choked flow. And this was all Jim. I barely knew what choked flow was. I knew that it had something to do with transport properties of gases at low pressure. And we both knew that probably the best subject matter experts on choked flow were aeronautical engineers. And we talked about having an outside subject matter expert come in so we could review the problems with this scale-up project. Well, it so happens that when I was on faculty at Purdue, I ran at lunchtime with a group of fellow faculty members, one of whom was John Sullivan. He was professor of aeronautical engineering, and at the time he was head of the aeronautical engineering department. So I knew John well enough that I was comfortable telling him a little bit about this problem and asking him if he would come down and review it with us and give us his thoughts. Well, in working with the Lilly folks who put contracts in place, they greeted this with a lot of skepticism. You want to have an aeronautical engineering professor to work for Eli Lilly? I think they thought it was some sort of a boondoggle, and I just wanted to have my friend down for lunch on Lilly's dime. But it turned out to be a really productive thing, because it resulted in confirming that the root cause of the scale-up problem was choked flow. So very useful in that regard. But there were more good luck things that happened, because in my trips back and forth to West Lafayette, I would stop in to talk to John, and he introduced me to a relatively new professor in the office right next to his. Her name was Alina Alexenko. And Alina and I then started meeting informally, but sort of semi-regularly. I was interested in questions like, how big a deal is thermal convection in freeze drying? Is it something you can safely ignore? So that was the subject of our early discussions, but that resulted in her inviting me to be on the thesis committee of a graduate student of hers at the time, Arnab Ganguly, who has since become a very good friend of mine. So that was a really productive interaction early on. And then the good luck continued, because very shortly after that, Liz Topp joined the Department of Industrial and Physical Pharmacy as department head. And I knew Liz as an excellent speaker, excellent researcher, great teacher, and I like to tell her that she's a very good explainer of stuff. So she and Alina, I don't know how exactly, but they seemed to start collaborating almost immediately, and it was that collaboration that was the origin of LyoHUB. And as I look back on my own career, one of the things I'm really proud of is that I had a small role in facilitating this interaction that was, right down to was really the origin of LyoHUB. And on a personal note, it resulted in friendships with some of the nicest people I know.
I'm David Broker. I am the Chief Innovation and Collaboration Officer for the Purdue Research Foundation. I started my career at Eli Lilly and Company back in the mid-'80s. I was a process engineer in the insulin manufacturing area. And this was right at the dawn of the biotech industry and the commercialization of biosynthetic insulin. But my first job before working in that facility, manufacturing facility in Indianapolis, was working in the original Eli Lilly and Company manufacturing facility for glandular insulin. That was just, back in the mid-1920s. Lilly used to number buildings in the year that they were constructed. So I started my career in a building called Building 25. This was one of the very, very first commercial insulin manufacturing facilities. And before biosynthetic insulin, insulin was manufactured by taking either cow pancreas glands or pig pancreas glands and extracting insulin out of it. This was all done in a collaboration that Lilly had with Banting and Best at the University of Toronto, who won the Nobel Prize back in the early 1920s, and it was a breakthrough drug back then. And so what was interesting was, related to lyophilization, there were two engineers, one on the extraction side and one on the purification side. And I was the engineer that supported the processes for the purification of insulin. So once the protein was isolated using some chromatography, it obviously had to be put into a finished form in a vial. And that involved freeze drying or lyophilization of the protein peptide. And back then, as you can imagine, back in the 20s and 30s, these lyophilization units were quite, I'll say, large, industrial looking. They were made out of, heavy material. The doors on these things, swung on hinges. They probably weighed several hundred pounds. And as the engineer working with the technicians in the manufacturing areas, you would take the vialed material that needed to be freeze dried and you'd load it into trays and you'd literally walk the trays into these big lyophilization units. And then you'd swing the door. I mean, it was like swinging a castle door closed, and you'd seal it all up. You'd turn the wheel, and it was almost like closing a bank vault. And then you'd start the process and pull vacuum and reduce the temperature. And I don't remember the details at this point of how long the cycle took. But when it was all said and done, you'd open this back up, take the material out of the freeze dry unit, and then away you'd go to the next step in the process. So that was my experience with lyophilization, working in Building 25. Obviously, when we launched the new biosynthetic insulin facility a few years later, much improved process, different kinds of equipment, much more, I would say, rigorous from a process and process control standpoint. So it was just amazing to sort of see just those changes that occurred. And what's exciting about the LyoHUB is you guys are advancing it now even further in terms of the way freeze drying is done, the way it can be characterized, looking at different opportunities around continued optimization of process and process control. So, we're approaching it's 2024. So 99 years ago, when you think about what lyophilization was and where we are today, it's just amazing.
My name is Sergey Chesalov. Pfizer is one of two companies who joined LyoHUB back in 2014, and But today I'm representing only myself, providing my personal opinion. So I was, as mentioned, about 10 years part of LyoHUB, and I really benefited not only from networking, but also from learning something new. And LyoHUB, in my opinion, is an organization who provides great science, and also, in my opinion, provides some vision on lyophilization field. 20 years ago, we had a lunch with Professor Alan Kinsey, and we asked him, Alan, what do you think about future lyophilization, regular freeze dryer? And he said, I think in the next 10 years, alternative drying technology like spray drying will replace it, or at least in some part of this. And however, if you look at the last trends for the last 10 years, you can see a significant increase in improved lyo products. And I think the part of that is because the technology become very efficient, and we learn a lot for the last 10, 20 years, and I think in part it's also because of LyoHUB.
My name is Arnav Ganguly, Associate Director for Engineering at Amgen, Thousand Oaks in California. I've been fortunate to be involved with LyoHUB since its inception, really. First as a student in Professor Alexenko's research group at Purdue, then receiving support from Ernesto, Michele, Frank, and others at EMA Life as LyoHUB's first member company back in 2014. I still remember the first formal meeting we had in Chicago, I believe just before the ISLFD meeting in 2014, laying down the foundation for what would become the goal for the first few years for the consortium. Among all, we agreed to work on providing a series of best practice papers in the field of lyophilization. I remember how excited we were back in 2017 after the first best practice paper was published, to see the number of views and downloads exceeding 600, very quickly 700 in a couple of weeks. And now, when I checked recently, there were in excess of 19,000 views and 70 plus citations on that one white paper alone, thanks to Steve Nail's leadership on that.
I'm Tian Thompson, the founder of Millrock Technology. We manufacture freeze-drying equipment and supply it worldwide. Back in the day, Alina Alexenko and Elizabeth Topp came to Millrock, and we discussed their vision for developing a community that can advance freeze-drying technology and advance the knowledge of freeze-drying. We were very excited to hear what their vision was, and we got together and decided that we should provide a piece of equipment for the initial laboratory. So we provided a Revo freeze dryer for the lab to enable them to do testing and to also test new technologies that they were developing. It's a great facility where people can come in and test their product and see how it will perform in a freeze drying process, and believe that it's been truly revolutionary for the industry.